Thanks everyone for joining today's webinar. I'm very excited to be here to talk about the capabilities and features we're bringing to SQL Server customers with Amazon RDS Custom. But before I start, I would like to quickly introduce myself. My name is Sudhir Amin. I'm a database specialist solution architect focusing on SQL Server technologies. And this presentation would be a deep dive into RDS Custom for SQL Server. And if you have a basic familiarity with RDS platform, it would be very helpful to follow along with me. With this, I can say, by the end of this presentation, you should be able to identify architecture scenarios where RDS Custom for SQL Server can be implemented. You should also be able to evaluate features of RDS Custom and design a database solution using RDS Custom. So let's get started. Let's quickly go through the agenda. I will start with the introduction and cover what is RDS Custom and what does the service provides. And then, with the use case and benefits, we'll go deeper into some of our customer architectures and talk about why RDS Custom was considered to meet those requirements. I will also cover some new terminologies and concepts that we introduced with the service. And finally, the demo. This is where I would like to spend most of my time. I have a lab environment to show different use cases that are now possible with RDS Custom. So we'll set up RDS Custom and configure it. So let's start with the intro. So what exactly is RDS Custom? It is a managed database service that provides granular control to access and customize the underlying operating system as well as the database on RDS Custom instance. What this essentially means, within the managed database offering, DBAs and sysadmins now have the full control over the underlying operating system of a RDS Custom instance. That is local administrator privilege at the OS level and sysadmin privilege at the database level. With this, customers now can use the super user privilege to make changes to the OS as well as the database. This means making changes to the administrator group membership, Windows registry, turning on SQL Server features and functionality at the database level. Customers can now make customization to RDS instance, such as installing third-party drivers and agents for different use cases, installing third-party security products for monitoring and auditing. With controls at the database and the OS level, they can also migrate workloads using native SQL Server application technology such as always on, transaction replication, log shipping. I will cover these use cases in depth as we move along. We launched RDS Custom last re:Invent supporting SQL Server 2019. As of now, we support memory optimized instance R and M families. RDS Custom instance supports hosting up to 5,000 database. This helps a lot of SaaS vendors to build their multi-tenant architecture on AWS cost effectively. Additionally, we also support point-in-time restore for up to 100 databases. The self-managed HA provides flexibility that the customers were asking for to support cross-region DR and migration use cases. Now let's understand what does RDS Custom platform offers in comparison to other SQL Server options. So as you see, RDS Custom sits right between self-managed EC2 and Amazon RDS, which is a managed database platform. So customers choose EC2 for its flexibility since it provides host-level access to configure and customize the SQL Server configuration or install software required by the application vendor. But in this model, you also manage your HA, backup, patching, everything very similar to the way you manage on-prem. On the other hand, customers who wants to get away from time-consuming tasks such as patching, backups, database upgrades, chooses Amazon RDS for its automation capability. With Amazon RDS Custom, you get both the automation of Amazon RDS and the flexibility of EC2. So in shared responsibility model of RDS Custom, you get more control than Amazon RDS, but it's also important to know that you have more responsibilities in terms of managing the backups, patching, and HA. And I will get into the depth. We'll talk about this when I do my demo. So how should a customer approach platforms while choosing the target architectures? We want customers to evaluate Amazon RDS first. It is important to review and validate your requirement against Amazon RDS to take advantage of managed database offering. RDS Custom is an ideal platform if you have a legacy, custom, or a packaged application that requires access to the underlying operating system and database environment. Also, if you need super user privilege to meet the vendor-based application deployment requirements. So in short, you're looking for a granular control at the host level and a database level to configure settings, install patches or software, or enable native features to meet the dependent application requirements. So apart from the granular control, RDS Custom can also be considered for migration and DR use cases. It's ideal for hybrid or multi-cloud DR strategy, and also to accelerate database migration with more control and flexibility using the native SQL Server applications such as log shipping or extending always-on clusters. And we'll talk about these use cases in detail as we move on. So let's take a look at the supported use cases for RDS Custom. All right, let's start with granular control. With granular control, RDS Custom now supports running extended store procedures, enabling CLR or turning on advanced features such as resource governor, or even enabling link server between different database engines. There are many customers who are running legacy application or a packaged application that depends on the super user privilege or these features that I just mentioned, such as CLR, XPCMD shell. They can be easily migrated and hosted on RDS Custom platform. You can also use RDS Custom as a disaster recovery target, as I mentioned in my previous slide. Just wanted to say, if you have more question or need more clarification, or even thinking about SQL Server specific feature as a use case, feel free to drop those questions in the comment section. We have volunteers from specialist SA org or even the product team, who can answer these questions while I'm presenting. I also would like to say that we have a Q&A session at the end. We can always go over that. Thanks. All right, so let's move on. Let's start with granular control use case as an example. Now with this setup, RDS Custom can easily join a self-managed Active Directory with the permissions you have on the RDS Custom instance. Similarly, you also have access to provide database access role, such as sysadmin, security admin. If your application required to be co-hosted on the database instance, you could do that as well by installing those applications on the RDS instance. A lot of customers run custom applications that require CLR as a functionality. That can also be that's also possible with RDS Custom. And apart from these, you can also scale your database up to 5,000. So that's another use case for SaaS vendors or customers who are interested in multi-tenant architecture. So all of these are examples of customization which are possible with RDS Custom. Let's look at another example. For enterprise customers, link server configurations are very common, where they have multiple relational database systems like Oracle, MySQL, Postgres, and they use link server to configure distributed queries across these heterogeneous environments. So with RDS Custom, you can install the drivers that are required for this link server configuration and configure a link server between these heterogeneous systems. That's another example. With RDS Custom for SQL Server, you can now migrate the database using always-on availability group between your on-prem instance and AWS Cloud. This architecture supports both migration as well as disaster recovery strategy in the cloud. So with RDS Custom, now the database administrators can configure async replication and manually failover between the two environments. So how to get started? You first set up your hybrid connectivity using AWS Direct Connect or VPN Gateway. If you need to move the database files like backups, you can configure AWS Storage Gateway, ideal for hybrid cloud storage strategy. Then set up your target environment using RDS Custom. Configure your on-prem database as a primary replica and configure a secondary replica on RDS Custom instance. And then configure this async replication between the two environments so you can manually failover the database. This works great as a disaster recovery target, but if you're looking to exit your data center, it can also be a migration use case. You can close your data center and decommission your database and migrate the workloads using this method. There are some new concepts that we introduced with RDS Custom instance that you should know before using the RDS Custom service. So let's understand them. Now that you understand that you have super user privilege to customize the RDS instance, it is important to understand how to apply the changes. To avoid the conflicts between your changes and RDS custom automation, we introduced these two new concepts, automation mode and support perimeter. Automation mode controls the Amazon RDS custom automation, such as monitoring, backup, and database status. And support perimeter determines if the customization breaks our automation. Automation mode is essentially a setting that you change before applying the customization. So basically, you modify the setting from full automation to pause state and then perform the change. And once the change is completed, you can switch it back to full automation mode. On the other hand, support perimeter shows the effect of your applied changes. It basically alerts you if the applied changes breaks the RDS automation. And I will talk about the example changes that breaks our automation in the next slide. So let's talk about automation mode. So you can think of automation mode as a software automation that runs outside of the database instance that continuously communicate with our monitoring agents and performs automated database tasks such as checking the database status, health check, and also performing backups. The primary responsibility of automation mode is to collect metrics and send notification, and also perform automatic instance recovery. And when your RDS instance is in pause state, it basically pauses the RDS custom automation. That includes database status monitoring, storage monitoring, EC2 instance status, automated backup, manual snapshots. And you can pause the automation instance up to 24 hours, which is more than enough to perform major or minor change on the RDS custom instance. Now let's talk about support perimeter. Support perimeter shows the status of your applied changes. So there are two status, available and unsupported configuration. So if you apply a change that breaks our automation, then the RDS custom will show the status of unsupported configuration. So let's say you place the database file on a remote SMB share. RDS custom automation will automatically put your RDS instance into unsupported configuration state until you fix it and place the database back onto the EBS volume that was provisioned with RDS custom and the one that RDS custom automation manages. And this is because the service continuously monitors the database status, performs database backup and other tasks, within the managed database offering. So we won't be able to do those tasks if we don't know about the volumes, right? So that's one example. Similarly, you should not stop the SSM agent or the RDS custom agent that runs on the instance. So any change that you make, if it affects the state of those services, the communication stops between the RDS automation that runs outside of the instance, and it will just simply mark the instance as unsupported configuration. Another thing you would need to be aware of is during the unsupported configuration state, you cannot modify the DB instance. You can't change the instance type. You cannot make any changes to it. You cannot take snapshots. No automated backups are created. And also, if the underlying EC2 instance is impaired, the RDS custom cannot do a host replacement. So these are the things you should be aware of. All right, it's now time to switch to AWS Console for the demos. But before I switch to AWS Management Console, I would like to take a moment and explain what are we trying to accomplish here. Here's the list of things that I would like you to take away from this presentation and the demo. First thing, I would like you to get familiar with the prerequisite to set up RDS Custom. We have documentation that covers this in detail, so I'll walk you through that. The next thing I want to show is the integration with AWS Systems Manager, and this would be very helpful for configuration management. And then I would like to show how to perform changes on RDS Custom instance, which means pausing the automation, performing the change, and then resuming those automation. I would like to show some changes that would affect the support parameters that you should be aware of. And we'll go through that. I have set up an environment where I purposely made some changes that would put this RDS instance out of the support boundary. And finally, we'll perform the change operation using the super user privilege both at the OS as well as the database level. So we'll use our first use case of setting up link server. So we can set up a link server on the RDS custom instance. So before you create RDS Custom, you would need a customer managed key. RDS Custom does not support AWS managed KMS keys. This is well documented in our AWS documentation page for RDS Custom. The next thing's a pretty standard procedure for any services, whether it's RDS or any other service we want to use. So the first thing you would do is you create an IAM role, attach all the permissions that is required for that service, and then create an instance profile, and then add the role to the instance profile, and then configure the VPC to allow outbound access to HTTPS, which is essentially required for most of our service endpoints. So RDS Custom would interact with several AWS services like CloudWatch, EventBridge, S3, System Manager, Secrets Manager, and outbound access for 443 is important. So just make sure that you have those endpoints configured. And then you can go and create an RDS Custom instance. This is the high-level architecture of RDS Custom instance. These are some of the main components that will get provisioned or will be interacting with RDS Custom instance. So as you can see, EC2, the operating system, file system, and the EBS volume where the database files would reside. And then you also have an endpoint to connect to for your clients. All right, so this is going to be our first demo, and it will be an example for granular control. So we'll set up link server on the RDS instance. So my goal is to basically to show the super user privilege that you have at the operating system level as well as the database level. So we'll go in the order. We'll connect to their RDS custom instance using AWS Systems Manager. So we'll try to set the password, run some commands against the RDS instance. We also will connect to the RDS instance using RDP. So we need to open the port. So we'll do those change operations. And I will connect one of my RDS instance to a managed Active Directory, the self-managed Active Directory. And then we'll install Oracle Client Software to configure the link server. So, and from a database perspective, I will create logins with sysadmin privilege and then configure the link server. So let's get started. Before you launch RDS Custom instance, go through our product documentation for RDS Custom. You'll find useful instructions to set up, operate, and manage RDS Custom instance. So go to our product page and click on this setting up your environment for Amazon RDS Custom for SQL Server. This is really important because it covers all the prerequisites in detail and also points you to a CloudFormation template that automates the deployment of these prerequisites. So if you're looking to do a quick POC or validate or test and validate any use cases, this CloudFormation template would be very useful. So in my account, I have downloaded this CloudFormation template and used it to deploy the prerequisite. So let me walk you through that. So this is the CloudFormation that I'm using. Yep. And these are the resources that it provisioned. So basically it created a VPC, customer managed keys, and all the required endpoints. And in the output section, it has all the information that I need to create a database instance, which is the instance profile, the KMS keys, the security group, and the VPC to target for. So if I want to create an RDS custom instance, I can use this information and deploy and test it. So basically now we have everything to get started and create an RDS instance. So let's go to the RDS Management Console. I'm going to click here. So I have almost like 6 database provisioned already. This is my lab environment. And as you see here, we have a couple of RDS instances with errors, incompatible network, and unsupported configuration. So these are some of the common errors we see customers run into. And this is why it's important to follow the documentation, understand the prerequisites. So let's start with the RDS instance with incompatible network. And let's go to the logs and events. So notice the error here. This RDS instance has connectivity issue and cannot communicate with our endpoints. Now let's see the other instance and find out why this is unsupported configuration state. Let's go back to the database and let's pick the database 3 and look at the logs and events. This RDS custom instance is complaining about the database file location. If you recall the slides earlier when I was explaining support perimeter, I mentioned that there are changes that will put the database instance out of the support boundary. And this is one example. If you create a database outside of the volume that the RDS automation supports, it will mark the instance as unsupported configuration. Let me explain why this instance is marked as unsupported configuration. So if you notice, this instance has configured capacity of 100 gigs of volume for EBS storage. And this is what the RDS Custom automation manages. RDS Custom automation is responsible for managing this EBS storage. It does the health check, it performs automated backup, manual backups. So it is important to place the database file back to the EBS volume to get this system back to available state. And if this RDS instance stays in this current state, then with this unsupported configuration, you cannot modify this instance, you cannot take manual snapshot, no automated backups would occur. And you can see here, it has stopped taking the automated backup. And also, if you click on modify, you will not be able to make any configurational changes on this instance. Let me click here and try to take a snapshot. Notice here, the take snapshot button is also grayed out. So it's important to undo those changes to get this system back to the available state. So now that you have a good understanding about the support perimeter as well as the prerequisite that you need to get started, I think we got everything covered since I've already used the CloudFormation template. So I'll go ahead and click on the create database and deploy an RDS instance. So let me click on the create database here. And for this demo, I will simply use Microsoft SQL Server, and under management type, I'll pick RDS Custom. For this demonstration, I'll select SQL Server Standard Edition. I'm not going to make any change to the version since it's the only version supported at this point. Let me quickly type my password. All right. For instance configuration, I'm okay with M5 X large instance, and I'll leave the storage defaults. So here I'll pick the VPC which was created with the RDS Custom. So I'm going to pick that one and the subnet group as well. For public access, I will choose no. I want the database to be in the private subnet. And then I'm going to leave the security group as default. But I think there are two more security groups that were created for VPC endpoint and RDS Custom instance. So let's use them. No changes to the availability zone. For additional configuration about ports, I'll leave it as defaults. And for IAM instance profile, I will choose the one that was created for my region, which is Ohio. So I'll pick this one. And then I will select the customer managed key that was created by the CloudFormation template. It seems like it's all configured so far. Under additional configuration, we have the backups. So I'm going to leave it as defaults. Maybe I can change the maintenance window here. I'll pick Saturday midnight for 4 hours. That should be good. And I have the delete protection enabled. So I'm going to simply click on the create database button. So this is going to take some time. So as you see, the database 7 is getting created. So let's move on to the next step. Let's talk about System Manager and how to configure these instances. As I mentioned before, prior to making changes, we would need to put the database into a pause state. So we need to modify the automation mode. So let's do that. Let's pick this RDS instance, DB4, and click on modify. And then under RDS Custom Automation, I'm going to select pause state, and I'll keep the default 60 minutes and click on continue. And I would keep the defaults and click on modify DB instance. Let me refresh it. All right, so now it's modifying. So we'll wait for a few more seconds, few more minutes, and then once the automation state would be paused, we can proceed further with AWS Systems Manager to configure this instance. All right, so now that its automation is paused, we can make the customization. So we'll start with AWS Systems Manager. So let's navigate to the Systems Manager. AWS System Manager has a rich set of feature sets, and we're focusing only on two of them for this demonstration, Session Manager and Run Command. And both of these capabilities within System Manager would help you to execute commands remotely on RDS instances. If you want to learn more about AWS Systems Manager, I would highly recommend to go through the product documentation. It's basically to manage a fleet of EC2 instances, perform remote administration, or patch management. There are several features that comes with AWS System Manager. But for this demonstration, we'll focus on Session Manager and Run Command. So let's go to Session Manager. Ideally, Session Manager would be when you're operating on one of the RDS instance node. So let's start the session on the database 4. So I'm going to click on Start Session and then select the database 4 and click Start Session. So this will open up another browser and it will connect directly to the CLI. So now I'm connected through the management console. I have access now to the RDS instance CLI. So this is the PowerShell CLI. So I should be able to execute configurational changes or any script that I want to configure. This is all great for one RDS instance, but if you want to make changes to more than one RDS instance and you want to have configurational changes applied to more than one instances, then I would recommend you to go to Systems Manager. We have a run command capability, and this basically allows you to execute changes on more than one instances. So basically, I'll go to the third page and pick the PowerShell script, and here I have the ability to use the PowerShell script. So I'm going to use a simple example like hostname, but you can use this for installing the SQL Server module or any other script that you use for database administration. So in this simple example, I'll just use hostname command, and then I will pick the instances manually. So let's say I'll pick the database 4, 5, and the 7. And I'm going to execute this hostname command against all these 3 instances. I do not want to store the output on S3, so I'm going to uncheck this one and simply click on Run. So now we're executing changes and the script on all of these instances. And let's just wait for a few seconds. It should return the message quickly. There you go. So it completed. And if you click on this instance and click on the output, you can actually see the host name. So this is an example of running configurational changes on RDS Custom instances. So RDS Custom works seamlessly well with AWS Systems Manager. And you can use AWS Systems Manager to configure RDS Custom instance. So we highly recommend customers to use Systems Manager because it is a secure way to access the CLI and also make configurational changes. Everything you do with AWS Systems Manager gets logged into CloudTrail, and you have a good audit trail to track the changes. But for some reason, if you're still comfortable with using Remote Desktop Gateway, we can also set up a Remote Desktop Gateway with RDS Custom instance. So in order to do that, I'm going to rerun this run command again on all the instances and set up the local administrator password, and also configure the firewall port to allow RDP. So I'm going to rerun this. Let's do that. Let's click Run Command. Go to the page 3. There's a PowerShell script. So I'm going to pick that. And in here, instead of hostname, I'm going to paste the command that I have. So here in this script, the first part of the script is going to get the secrets from AWS Secrets Manager and set the local administrator password. And the next command is basically to set the firewall rules to allow remote desktop protocol. Now, I will run this command against a couple of instances which I need to configure. So let's pick 4 and 5. And then again, I will not choose the output option for S3. So I'm simply going to run this command. Let me quickly refresh this. It's going to take a few more seconds, a few more minutes. All right, it seems like the command ran successfully. Let's verify this. Click here on the instance and click on the output. Yep, looks great. So we set the local administrator password and the RDP protocol is enabled. So now let's get the endpoint from the RDS Management Console and try to remote login using the RDP session. All right, so let's click on the DB instances and let's configure the database for this. So let's get the endpoint address. So let's click on database 4. And here we have the endpoint address under connectivity and security. Let me copy that. And then I have a remote desktop session for my jump box. So let me bring that up. Perfect. So before I connect, I want to verify the name resolution. So let me click on the Windows PowerShell and do an NS lookup. Sorry. Perfect. So everything looks great. Let me close this and try to RDP. I'm going to paste this endpoint here, click connect. And now I will log in with the administrator credential. So let me change that. All right. So now I'm logged into the RDS instance remotely using the RDP protocol. So let's make first change here. Let me click no here. So let's make the first change here. Let me bring up the server manager. And I would like to connect this instance to the domain. Click workgroup, click on change. Let me click on the domain, click awslabs.com. I'm going to put the admin credentials. Oops. Let me try one more time. Perfect. So welcome to AWSLabs.com. So this machine is now part of the domain. I'm going to quickly close it and restart this instance. So let's give it a few minutes, let it reboot. Meanwhile, let's come back to the console and see if we want to make any other changes. So we'll connect this instance to the domain, and then we'll install the Oracle client libraries on this instance. So notice here I have another Oracle Enterprise instance here. So I'm going to set up a link server between database 4 instance and the Oracle instance. So let's wait for a few more minutes, and then I'll try to connect one more time. All right, seems like we spent enough time. So let's try to connect back to the remote desktop gateway connection. So let me bring up my remote desktop instance. Let's try one more time to connect, but this time we're going to connect to this instance using our domain credential. So let me quickly change this to AWS Labs /admin. All right, so now I've logged into this instance using the domain admin credential. So let's take a look at the SQL Server as well this time. And let's do a database level change here first. Let me open SQL Server Management Studio. The first time I'm going to log in using the SQL Server authentication, and then I will assign the domain admin credential to well, I will create the logins for domain admin credential and then provide the sysadmin privilege. So let's wait for a few more seconds. All right, so let's use the SQL Server authentication and use the admin credential. Okay, so under security, I'm gonna create a new credentials for this domain user. Admin, and then under server role, I'll give it sysadmin, security admin, database creator. This should be good enough to show that this is possible with RDS Custom instance. So I'm gonna click OK here. There you go. Perfect. So now let me disconnect and reconnect to this instance using the domain admin credential. Let's switch back to the Windows authentication and click on connect. Perfect. So now you're logging in to the SQL Server instance with the domain admin credential. So the next step would be to install the software. So for this, I have a FSX file share, a Windows FSX, where I have the software packages. So let's go to the FSX and collect the endpoints. So this is the share where I have the Oracle Client Library software. So let's go back to the remote connection. Click on Start, Run. I'm going to use that file share to access. So in this directory, I have this software. So what I'll do is click on, open it and run through this wizard. Let's install this software. Click on yes. So this is the Oracle Client Library that I will install on this host for link server configuration. Let's click on yes. I haven't set the environment variable yet. I will set it up as soon as I finish this installation. Click next. I'll pick the language defaults. Here I will change it to the C drive. Click next. Let's pick some client libraries. So the important one is the Oracle ODBC and these two. So hit next and then click on finish. So it's going to take some time, a few more minutes, and that should be it. So let's wait for a few more minutes till the installation finishes. All right, so the client library was installed successfully. Just click on close and close this. Now let me refresh this this window. Let me just do a quick refresh. All right, so under server object, under link server, I will check the provider. Now notice here I have the Oracle drivers now installed. So this is important to configure the link server between Oracle and SQL Server. All right, now that the software is installed, the only step remaining is to actually configure the link server, which we can do it once the environment variable is set up and you have a network connectivity configured properly on this instance. And this instance should be able to communicate with the Oracle instance. So for that, I have a SQLnet.ora and the TNS names.ora, which is related to Oracle client libraries and also network connectivity with Oracle server. So I'm going to simply paste the file into the right directory so that we have the correct network connectivity with the Oracle instance. So for that, I'll just quickly go to the directory. Let's navigate to the C drive where we install the library and navigate the product, the client version, network admin. This is very specific to the Oracle. So what I'll do is before I paste, let me just give permission to this directory for all the authenticated users. So now I can go ahead and paste it. Just simply paste it and quickly test the connectivity with the Oracle instance. So I'll do the TNS ping ORCL because that's the endpoint that I'm configuring. Perfect. So I see a positive resolution response. So I'm gonna go ahead and configure the link server now. So let's do right click, create new link server. I'm just gonna name this as link server, and I'll choose the Oracle library here and give the product name Oracle and the data source, the one that I just pinged. So under security, I will specify the Oracle instance admin credential. Perfect. Now I'm going to click on OK. Perfect. So now it's configured. Let me quickly test this connection. There you go. So we're all set with our first use case. We were able to successfully configure this instance as a link server. So with the next use case, I would like to show the flexible disaster recovery or migration strategy using RDS Custom instance. So with this, I would like to show in my lab environment how to migrate a SQL Server workload using always-on cluster, always-on replication technology. So in this lab environment, I've used Microsoft AD, which is managed AD from AWS, which is fully managed service. And then I've used technology like Windows Failover Cluster, Amazon FSx for Windows File Share to host the backups, and then set up always-on availability group and configure the primary and the secondary replica. So let's go over this. So in this architecture, we are using two regions, Region A and Region B within AWS to mimic the corporate data center and AWS cloud. So on the left, you see the Region A. This is where I have configured the primary site where I have two node always on cluster. And then in the secondary region, Region B, I have the RDS custom instance configured as a secondary replica. And with this architecture, I would like to show both migration as well as the disaster recovery use case. So it's pretty straightforward. Let's go to the AWS console and see how the environment is set up. So far, we've been operating out of the Ohio region. In order to show the migration use case, what I've done is I've used North Virginia as my primary site and Ohio as a disaster recovery target site. So notice here the database 2 is working as a standby replica for the clusters running in the primary region, which is in the North Virginia. And to mimic the on-prem and the AWS cloud, I'm using the VPC peering. So a VPC running in North Virginia region is paired with the VPC running in the Ohio region. So let me quickly show that. Let's go to VPC in the Ohio region. Let's go back. So let me quickly filter the DR VPC. Click on your VPC. So this is the this is the DR VPC with 11.address. And if I look at the peering, it is paired with the 10.address running in another region, which is North Virginia. Let's go to the North Virginia region. And you will see the similar peering with the Ohio region. So let's navigate to the production primary VPC, which is the primary site. Now here, when I go to the EC2 instance, I should be able to see two node clusters. So node 001, node 002 are the two primary and the secondary replica running in the primary site, which is North Virginia. And in Ohio, we have RDS Custom instance replicating. So this is from the AWS console. Now, one more component that I want to talk about is the directory service. So let's go there. So we are using multi-region managed AD. So notice it's a multi-region with Enterprise Edition. So it currently supports replication to the Ohio region. So So we're using the stretched managed AD replication. And this is mimicking the exact behavior of how you extend your Active Directory into AWS Cloud. So this should be pretty straightforward for a Windows administrator. So let's go back to the EC2 instance. So we're good here with this 2-node cluster. So what I'm going to do is now quickly go to the jump box and show you from the OS how this setup look like. I have the remote connection. I'm using remote desktop connection manager. So here I have the remote connectivity to all the 3 nodes. This is the RDS instance in Ohio region and the 2-node cluster running in North Virginia. From a Windows Server cluster perspective, if I click on nodes, I have a cluster configured, 3-node cluster configured within the failover cluster manager. So test cluster is my Windows cluster where I have these 2 nodes configured. So notice the IP addresses. So 11.address is the one running the RDS custom. So this represents the RDS custom. The other 2 nodes are basically coming from the North Virginia region. So if you see right now, the 10.address is the primary node. The other 2 addresses are offline because they're secondary replica. From a SQL Server perspective, if I could just expand these guys. So node 1 is a primary site. So let me expand this one. So node 1 is the primary. The other 2 are the secondary replica. So let's go to the property of the always on cluster. And let's see the replication. So from node 1 and node 2, we're using synchronous replication with automatic failover. For the disaster recovery node, which is in the other region, we're using asynchronous commit. And that's the recommended practice because it's geographically far away from this instance. And we are using the manual failover mechanism here. All right, so let's click on OK here. And what I'm going to do next is basically perform the failover. So from the node 1, I'm going to do a failover of the database across to the RDS instance. So let's go through this wizard, click next, and then select the RDS Custom instance and click next. Notice you will see the warning, and this is due to the asynchronous replication configured. So I'm going to click on this checkbox just to confirm that failover will have the potential data loss. And that's just the nature of the asynchronous replication. And now I'm going to click on connect and connect to my RDS instance, click next, and then click on finish to let the failover complete on its own. Let's just wait for it to complete. All right, so this is a lightweight database, very small database. We just wanted to show the technical feasibility of configuring 2 different environments, one running on EC2, the other one on RDS Custom. So let's click on close, and let's come to the RDS instance now. Let's expand the availability group and the replica. Notice now the RDS Custom is the primary. And if I click on the availability database, I see green for the database. So perfect. Let's go back to the node 1 and refresh this guy. So we have to make some changes to the replication because notice it was synchronous replication. Now we need to resume the replication on the node 1. Perfect. So now here I need to resume the replication from the new primary. So before I do this, I also want to say that the replication is configured synchronous. So we need to make that change, but it's important to see the first error so that you don't make the mistake in your production environment. So let's click on resume data and I'll click OK. And I'll do the same thing from the the node 2 as well. So let's go to node 2 and refresh this guy. And I'll do a resume data movement and click OK. All right, let's come back and let's go through the dashboard. Let's shrink all this. Come to the primary and look at the dashboard. All right, so this behavior was expected, and this is one of the part of my demonstration, that the synchronous commit needs to be changed prior to failover. So I'll make that change right away. Let's go there. And I'll change this back to the manual and click OK. And as soon as I make that change, you see it turns into green. So now the status looks okay. Now this is a failover. This is just a test failover. And there are various things that you should consider before you perform such activities, which is like your application connectivity and bandwidth requirement, the size of the database, and the replication lag. So there are so many things to consider before you do this test failover in your production environment, or even your development, or even in your development environment where you're doing POC. Now, for this demonstration, it's a lightweight database. So this is more of a technical feasibility check to see if you have everything covered on RDS Custom. So this should be pretty straightforward to test and see how the configuration works with RDS Custom and EC2 instance. And it wouldn't be any different than you do with your on-prem workloads. And as a next step, please reach out to your AWS account team to schedule a workshop or a deep dive session. You may also want to do a POC, a proof of concept, to validate your use case. So if you need help with that, our team can definitely help you with that. And finally, I just want to say, if you're new to AWS, I would highly recommend you to create an AWS account and play around with AWS services available in the free tier. So with this, we're now open for the Q&A session. So thank you for your patience so far.